Hello, so welcome to your second video of the second chapter. I am mixing things up, so if you look at the reading, it actually puts this particular information in the third section, but I felt like this information goes really well with properties. So I wanted to make sure I kept those two things together. This coincides with all of the stuff we have been doing in the lab, especially today. You saw a bunch of changes that happened, so hopefully this information in this video will help solidify some of that information. Remember, we do have a quiz coming up, so you want to make sure that if you're not understanding this right now, you're coming to see me, you're talking to me about the things that you just don't think make sense. After this video, you should be able to identify the chemical properties of a substance, describe chemical changes and differentiate them from physical changes. Use various visual clues to identify whether a chemical reaction is taking place. Again, you have seen all this stuff in the lab. This information is really just solidifying that. We will talk about this in class in the next couple days, so please don't freak out if you're like, I still don't understand this. I will explain it all. It'll all come full circle as we progress throughout the week. Okay, so some questions I really want you to consider right now is, what is a chemical change? What does that look like? What do you know about a chemical change right now? How is that different from a property? Remember, I gave you the basics in class when I said a property and a change. So the change is the action and the property is actually the describing feature. So how are you really going to see that when we talk about chemical properties and chemical changes? Because it kind of seems like with chemical, at least when you're permanently altering the identity of something, that they seem like the same thing. You can say something's flammable, but you truly don't know that until you actually put it in a fire. Compared to something like color, which is a physical property, you can easily identify that property just by looking at it. So we left off talking about physical changes in the last set of notes. So now we're going to go ahead and bring in chemical changes. So bear in mind that a chemical change is something that permanently alters the identity of a substance. So after a chemical change has taken place, the substance is no longer what it used to be. So a great example, and the example I tend to always use, is rust and iron. So I have iron, and great, it looks great, it's beautiful, but then once it's exposed to air and the presence of water and everything else, it will eventually begin to rust. Rust is not iron. They are not the same thing at all. They have completely different chemical properties. Rust is obviously a more brittle, very much a different color. So all of these things indicate that we have a chemical change that has happened. And so let's go ahead and backtrack a little bit. A chemical property describes the ability of a substance to undergo a specific chemical change. I gave you a little bit of a different definition in your previous notes, but this is all along the same lines, that it has the ability to change into something else. So when we talk about iron, remember that we are completely altering the identity of the substance. We're completely changing it on the chemical level. So another nice name for rusting is actually corrosion. And a lot of things go through corrosion. They break down. They don't form what they used to form anymore. And so other words to describe this kind of, I can't even think of the word I'm trying to say. This phenomenon, I guess, is things like burn, rot, explode, decompose, ferment. Those are all ways of saying that something is breaking down or turning into something else. Chemical properties are a very useful way to identify substances. So, for example, if I have two white powders and they look exactly alike, like all of their physical properties are the exact same, how am I going to distinguish what is from what? And we have this in the lab. I have tons of white powders in the lab. And if I didn't have the label for them, then I'd have to actually test it. And physical properties can only take us so far. If both of the white powders act the same in everything else, and then I put one white powder in water and it explodes and the other dissolves, that's an issue. Like, I want to know that before I put them in water. So this is where these chemical properties come in handy. They can help us, like I said, identify a substance, see if there's a precipitate that forms. And if you don't know what that is yet, and we'll talk about that in the next video, but you should have already seen that in lab. But again, these are all features that help identify a substance even further. A great classification tool. Unlike physical properties, though, chemical properties can only be observed as the substance is in the process of being changed into a different substance. So you cannot actually test these properties. I can say anything is flammable, but I don't truly know it's flammable until I actually test it. So you can't actually see the property in its place until you're actually doing the change. So chemical changes and chemical properties really do go hand in hand. And a great name for a chemical change is actually known as a chemical reaction. And we use this all the time. Chemical reaction is a process that occurs when one or more substances are changed into one or more new substances. So chemical reaction. And remember, we always balance these chemical reactions. We start balancing chemical reactions here soon, but also please bear in mind or make sure you know at this point that a chemical change and a chemical reaction are the same thing. Some things to remember about chemical changes, also known as chemical reactions, is we have some reactants and we have some products. On the left side, you will find the reactants, and on the right side, you'll find the products. There must be some energy present, known as activation energy. This is the energy that's required to get the actual reaction going. So for example, if I mix two things, let's take zinc and sulfur, and I mix the two, nothing is going to happen. But if I then give it some more energy, so I provide it in, like, let's say I heat it up, you're going to see a reaction. So I need to have that energy present in order for this reaction to go. And this is true for all things. Some reactions happen spontaneously, as in like I put them together and they'll go, but a lot of them require heat or some extra energy in order to get going. Some great hints to tell you that a chemical change is actually taking place are very visual clues. Like if you can't see something, smell something, like feel the touch or the heat, then there's probably not a chemical reaction going. So some great indicators, a color change of some sort. And I know, like when I talk about dyeing, like dyeing as in dyeing my hair, there are some dyes that will wash out. So that's not a permanent change, but typically when you see a color change in a reaction and you know you're actually doing a reaction, that is a good indicator a change is happening. Better indicators, a gas is produced during that reaction. You did see that in lab. You produce hydrogen gas and other substances. A solid product called a precipitate is produced in the reaction. You also saw this. A visible transfer of energy occurs in the form of light as a result of the reaction. So if you see something flaring up, those are really good indicators. And there's more than just that. Those aren't the only indicators of chemical reactions, but those are the very obvious. And typically, one of those four is always going to happen in a reaction. Like I said, if you feel heat or cold, that's another indicator. You should never taste anything in the lab, so that's not even an option here. Ooh, and I did tell you that a precipitate we're going to learn about in the next video, but I lied. We're actually learning about it right now. A precipitate is a solid product that forms from a reaction and settles out of a liquid mixture. You did see this in the lab when you mixed ammonia with copper sulfate and you saw that like big glob thing. That's a precipitate. It's a great way to show you that a solid is formed from the combination of the two. So an actual chemical reaction has happened. What you actually saw in the lab was a single replacement reaction, which we will talk about in more detail later. Another thing I already mentioned, but I want to mention again, all chemical changes involve a transfer of energy. So we're not like losing any energy and we're not creating any energy, but we are transferring the energy from one state to another. Now, that's not to say that physical changes don't actually cause a transfer of energy, because like when I melt something, it's hot, but I did not cause a chemical change. I still have that same product or that same substance. So those are things to bear in mind, that you can easily confuse physical changes with chemical changes. So you'll always want to test your product to make sure it's actually something different. And I'll kind of walk you through this. I will walk you through this in the lab. So please don't like freak out. I'm not going to trick you. The things we will be doing in the lab are very obvious, and to the eye, you can tell if a chemical reaction is actually happening or not. If you have any questions, please make sure to ask me on Edpuzzle. I'm pretty sure this is my shortest video of ever. See you later.